Good morning friends. Today discussion with design of one-way slab. Okay, design of one-way slab. One example problem: design a simply supported RCC slab for a veranda of clear dimensions 3 meters into 9 meters. Width of supports is 250 mm. Superimposed load is 3 kilonewton per meter square and weight of finishing load 2 kilonewton per meter square using M20 grade of concrete Fe 415 steel. Okay, given data: RCC slab clear dimensions 3 meters into 9 meters. This is the veranda 3 meters into 9 meters. 3 meters is a shorter direction, 9 meters is a longer direction. Shorter dimensions is Lx, longer dimensions is Ly. Okay, given data. Supporting weight, wall thickness is 330 mm. Superimposed load is 3 kilonewton per meter square. Finishing load is 2 kilonewton per meter square. Grade of concrete using an M20 grade of concrete and Fe 415 steel. For example, the ratio of longer span by shorter span greater than 2 is called as a one-way slab. The ratio of longer span by shorter span less than or equal to is called as a two-way slab. This is the longer direction is 9 meters, shorter direction is 3 meters. Then 9 by 3 is equal to 3 meters. Then greater than 2, this is called as a one-way slab. Next, second step, thickness of the slab. Then slab thickness. Then assuming the depth range for one-way slab span by 25 to span by 30. That the range of depth of the one-way slab, span by 25 to span by 30. Then I am analyzing an example span by 25 ratio. Then span is shorter span is 3000 by 25 is equal to 120 mm. Then effective depth is 120 mm, only effective depth. Then overall depth capital D is equal to effective depth plus using an M20 grade of using an M20 20 mm dia bars and 10 mm clear span. Then effective depth 20 plus 10 by 2. Then overall depth is 120 plus 20 plus 5. Then overall depth is 145 mm. Okay, next another step, effective span. Then effective span is clear span plus D. Then clear span also 3120. Okay, clear span is 3000 plus effective depth is small d is equal to 120. Then 3120 mm. Then again, in case effective span wall thickness by 2 plus clear span plus wall thickness by 2, then wall thickness is 330 by 2 plus clear span is 3000 plus wall thickness 330 by 2, then total is 3230 mm. Okay, then finally consider the clear span plus D value and effective span value. Consider the almost least value for effective span is 3.120 meters. Then another step number 4, loads. First one, self weight of load. Self weight of load is overall depth into unit weight of RCC. Overall depth is capital D is equal to 145 mm. Then meters is conversion 0.145 into effective unit weight of RCC 25. Then 3.625 kilonewton per meter square. Then again live load or superimposed load acting at a 3 kilonewton per meter square. Then floor finishing load is 2 kilonewton per meter square. Then total load. Then self weight plus live load plus floor finishing load. Then 3.625 plus 3 plus 2. Then total load is 8.625 kilonewton per meter square. Again total load into factor load. Factor load of concrete is 1.5 into total load. Then factor load 12.93 kilonewton per meter square. Next another step, factored bending moment. This is a simply supported beam. WL square by 8 is a bending moment. WL square by, and then W is equal to total factor load into shorter span direction. W 12.93, L is equal to 3.12 square by 8, WL square by 8. Then bending moment, factor of bending moment 15.73 kilonewton meter. Then again calculate the shear force. Shear force is a WL by 2. Then W is a total total load, total factor load into clear span 3.12 by 2. Then factor of shear force 5.04 kilonewton meter. Next step, minimum depth required. As far as minimum depth required by using in grade of concrete, for example Fi 250, that the value is 0.148 FCK BD square. In case Fe 415 steel 0.138 FCK BD square. In case Fe 500 0.138 FCK BD square. This problem Fe 415, then depth is 0.138 FCK BD square. Okay, then find the depth value is 75.49. Next, another step, tension reinforcement, finding the capital AST. Mu is equal to 0.87 Fi AST D into 1 minus Fi AST by FCK BD square. Then find out the AST value 389.26 mm. Okay, minimum AST is 12% of gross area. Gross area 12%, 0.12 by percent value 100 into B into capital D. Then AST minimum is 174 mm. Then find out the Mu is equal to 0.87 Fi AST by Fi AST into D into 1 minus Fi AST by FCK BD square. That value capital AST 389 is more value. Then finding the AST is safe. Then tension reinforcement at spacing. Then spacing is equal to small AST by capital AST into 1000. Okay, where small AST is providing bar area. By assuming 10 mm dia bars, that the area is pi d square by 4. Pi into 10 power of 10 square by 4 is equal to 78.53 mm square. Then finally spacing is small AST by capital AST. Small AST is 78.53 by 389.26 capital AST into 100. Then spacing is 201.74 mm. Okay. Then maximum spacing at tension reinforcement 3 into D as far as IS 456 2000. Then 3 into D is a small depth is 120 mm. Okay. Then 360 mm. Then again depth is also safe. Then finally providing as a tension reinforcement 10 mm dia bars at 200 mm center to center. Next step, distribution reinforcement. The distribution reinforcement will providing at a 0.12% of gross area. Then find out the capital AST 12%, 0.12 by 100 into B into D. Then AST is equal to 174 mm. Okay, then spacing of distribution bar small AST by capital AST into 1000. Again using in 8 mm dia bars, assuming spacing is pi into 8 square by 4 by 174 is a capital AST into 1000. Then spacing is 288.88 mm. Okay, then maximum spacing for a distribution bars 5 into D. Again tension reinforcement maximum spacing 3 into D. Then maximum spacing of distribution bar 3 into D 5 into 120, then 600 mm. Okay, maximum spacing 5 into 120, 600 mm. Then finally providing as a distribution reinforcement 8 mm dia bars at 280 mm center to center. Check for deflection. Find out the percentage of steel AST into 100 by BD. Then percentage value 0.324. Refer the IS 456 2000 code book, table number 19, page number 78. Find the percentage of steel depending on grade of concrete, M20 grade of concrete. Depending on find out the shear strength value using in IS 456 code book, table number 19. Next, see that the graph AST value 0.324, depending on percentage of steel 0.25, that the M20 grade of value 0.36, then 0.50 value 0.48. Then find the 0.324 value in shear strength value. Okay, then shear strength value by using an interpolation method, y1 plus y2 minus y1 by x2 minus x1 into x3 minus x1. Then y3 value, percentage of steel value 0.395 Newton per mm square. By using IS 456 2000 code book, page number 38. Refer the IS 456 2000 code book. Then modification factor, page number 38, figure number 4. Then Fs value is 0.58 into Fi. Fi is 415. Then Fs value is 240 Newton per mm square. Then also modification factor in y direction is modification factor value, x direction is shear strength value. Then curve value is 240. Then find the modification factor is 1.5. Then 1.5 into FCK. Then modification factor 1.5 into FCK. FCK is 1.5 into FCK is grade of concrete 20. Then modification factor 30. Then L by D ratio is 26. Then modification factor value 30. Greater than 30 L by D ratio compared to modification factor value is high. Then deflection is safe. Thank you. Subscribe.